Hi there, and welcome to yet another tutorial for the MIIA robotics platform. In this tutorial, we'll be taking a look at functions, what they are and how they can be used when writing programs. In a previous tutorial video, we spoke about two important functions that make up any piece of code that we write for the Arduino microcontroller platform. These are the setup and the loop functions. Just to recap, the setup function contains code that is only run once every time the Arduino microcontroller is booted up, and the loop function contains code that runs indefinitely as long as the microcontroller is running. So first the setup code gets run, thereafter the loop code gets run and gets run indefinitely until we either reset or power down the board. In programming, functions are a very important concept, and good practice in using them can greatly improve the readability and efficiency of your code. Let's take a look at an example of how functions can help us. But first, let's get set up so that we can actually see what we're outputting. We'll be using the serial monitor to see the output of our program. So we initialize the serial library and establish serial communications with our microcontroller. In the loop function, we'll do the following. We'll initialize a variable a to the value 1, we'll initialize the variable b to the value 2, and then we'll initialize a variable c, or rather declare it. So we have an integer a which is with the value of 1, we have an integer b with the value of 2, and then we have an integer c. And now we want to say c equals a plus b. Pretty obvious what the answer would be, right? But let's just print it out to our serial monitor to be sure. And we upload our code. Once the code is uploaded, we open up our serial monitor and we see what we get. Okay, so we see it continually printing out 33333. Again, it's doing that because we put that bit of code in the loop function. Probably not the most efficient way to do things, but for the purposes of this tutorial, we would just like to demonstrate a basic program flow. Alright, now let's say you actually wanted to add not 1 and 2, but rather 4 and 7. You'd have to manually change the values as I've done, and then upload the code again. Open up our serial monitor and we see 11 pops up. Okay, that's fine. Not much work to change the value of c. But let's say we actually wanted to do another one. We wanted to have another variable d, and we wanted d to, be the sum of two other variables, or c and f. So what we then need to do is, we then need to first of all initialize f to be 10, and then we need to initialize, well, we'll use the c value that we have, and then we'll need to print out the value of d. Over there, and we upload our code and we open up our serial monitor and we see 2111. Now the reason why we're seeing 2111 is because, anyone have an idea? Right, so the value of c is 4 plus 7, which is 11. The value of f is 10. And the value of d is c plus f, which is 10 plus 11, which is 21. But the reason why we've got it printed out together is because we used the print line function over here and just the print function for d. So my mistake, but let's quickly fix that. There we go. Let me just stop that. So here we see 11, 21, 11, 21. And again, this is repeating itself because it's in the loop function. So you might say, okay, cool, we can just keep adding more and more of these, declaring variables and initializing them and then printing them out for as many, arithmetic sums as we'd like to do. But what if you wanted to do 10, 100, or even 1,000 of these? It becomes very tedious and monotonous to type out the same code over and over again. And that's where functions come in. Functions kind of allow us to create modular pieces of code that perform a defined task. For example, in this case, we'd write a function to add two integers together and print the answer to the serial monitor. Let's take a look at how we can do that. The first thing we want to do is, when writing a function, we need to say what the return type is. For the purposes of this tutorial, we'll keep it simple and use the return type void. That means our function won't return anything. I'd like to point you to another tutorial where we look at variable types and look more in detail into how functions can be used to return values. But in this tutorial, we're just looking at how to write a function and how to write a modular piece of code that performs a defined task. We then want to give our function a name. So in this case, we'll call it add integers. We then need to specify what parameters our function takes. In this case, we're taking two integers, a and b. And then we use curly braces that contain the body of our code. So what we're then doing in this function is essentially what we did up here. We are going to say int c, and then we are going to say c equals a plus b. And finally we'll say serial print line c. So think of it like this. What this function is doing is it's saying this function is called add integers. It takes in an integer a as a parameter and it takes in an integer b as another parameter. Inside the function itself, we are declaring an integer c, and we are then assigning the value of a plus b to the variable c. Finally, we are then saying serial.println c, printing c to the serial monitor. So let's take all this out, and you're probably wondering, okay, we've got this function, but how do we use it? Two things. First of all, we need to declare the function. Typically, you need to do the function declaration before you call the function. Calling the function is how we use the function. The function declaration is simply just the first line of your function definition. This basically just tells the compiler that this is a function that exists somewhere in our code, and we will probably make reference to it before we actually get to the definition. So in this way, we can call add integers in setup or loop before we even get to add integers, the definition of the function. Another word for the function declaration is the function prototype. So now we've got our function prototype and we've got our function definition. What we then want to do is call our function. And to do that, we simply give the function name and we then give it the parameters. So this function needs two parameters, two integers a and b. So let's say we'll give it 10 and 14. We then upload our code and we see the value 24 being printed out. Now the beauty of functions is that if I want to add another two variables, I can just call the function again and change the arguments that we give it. So we see 24 and then 55 being printed out. So in this way, we are essentially running this bit of code twice, but with a lot less, type in footprint that we have to do. So instead of just rewriting this code twice, we write it out once, wrap it up in a function, and then call that function as many times as we'd like. And as you can imagine, you can probably go ahead and do multiple of these and give it different parameters and get the same outcome for each one. There are a lot of built-in functions that we've probably already been using throughout these tutorials. For example, the serial.begin is a function that initializes serial communications, as well as the serial.println, and also the setup and the loop are also functions that the Arduino compiler understands. So again, functions are modular pieces of code that perform defined tasks, and the beauty of it is that we can essentially repeat snippets of code to perform a certain function without having to retype all that code, and we can change the data that the function operates on. In a future video tutorial, we will look more deeply at functions and how we can actually return data from functions, and we'll also be looking at how to specify and look more deeply at the function return types. With that, you are one step closer to programming for the MIIA robotics platform. Hope to see you at the next tutorial, and thank you.